Hello everyone, today we are going to explain our subnetting. As we mentioned before, all addresses are actually allocated by an organization called IANA. It allocates them to countries, and countries allocate them to operators. The operators then allocate them to us. For example, here they gave me an address range of 1.0.0.008. What class is this? It's a Class A network, right? A Class A network actually has over 16 million addresses. So, during this process, can I allocate all these 16 million addresses to one country? Is it possible? But if we are all within the same subnet, I can communicate directly. However, it's impossible for everyone to be on the same subnet. For instance, if there are two competing companies, can I know the other company's network? It seems the privacy is somewhat lacking, and during this process, we will look for the same IP address in the future. The efficiency of finding it also decreases, making it difficult to locate the other party effectively. Therefore, we will differentiate subnets to some extent. So, what issues arise if we don't divide subnets? One department's IP address is 192.168.2.1.0214, and another subnet is 192.1168.22.0 with a 24-bit mask. I assigned this subnet to another department, so what do I use for the third department? I use 192.168.3.0. With a 24-bit mask, now within this setup, each department has a different subnet. So, do you think there are any issues in this process? Looking at our different departments, it's very likely that the number of computers in each is not the same. Now, for example, within this setup, 192.168.1.0 is for our finance department, which only has 30 computers. Our 192.168.2.0 is for our HR department, which might only have 10 people, while 192.168.3.0 is for our technical department, which could have 100 people. Assuming, in this process, how many can each subnet be allocated? Each can be allocated 254. So within each subnet, a lot of addresses are actually wasted. But you might ask, is it a problem if we waste addresses in our current network? Actually, it's not a problem. However, if the place you're at is a data center specifically for storing servers, for instance, if our company currently has a server hosted in a data center, in the future, we will need to apply for public IP addresses. Let's say, I only need 10 here. Do you think the data center will give you 254 addresses? Probably not. And it wouldn't be appropriate either, because public IP addresses here cost money. It's not possible for you to pay so little and end up getting so many addresses. For example, when we want to access the internet, we all have to go through an ISP. But if, for instance, we set up a dedicated line here and are given a fixed address, and in the future, I use this address to access the internet, would they give me something like 100.1.1.2.2 with 14 bits? This is also impossible because they cannot allocate the entire network segment for you to use. In this process, firstly, in such a situation, which we don't often encounter in our current network, it usually involves the service provider and our data center. What? But now, if we follow the previous classification of A, B, and C types, that is to say, the subnet masks are 8, 16, and 24 respectively. So now, in this context, it is very likely that too many addresses will be wasted. In this context, not only will addresses be wasted, but it will also result in an excessively large broadcast domain. Sucks. Once a broadcast occurs within my broadcast domain, the internal network will become overloaded due to too many devices. Therefore, in this context, I don't have to follow the 8 or 16 subnetting. Instead, I can divide it into multiple smaller subnets. For example, using a 14, each subnet can be assigned its own separate broadcast domain. By doing this, I can make my broadcast domains smaller, my network segments smaller, and the network planning more reasonable. Suppose we now see an initial IP segment here. Here, one network segment is 192.168.10.0, which is a Class C address. Its default value for the subnet mask is 2 to the power of 14, right? If we want to calculate its network segment, here, including the number of available addresses, we first need to convert it to binary. If it's R5, it represents 8 ones, and the corresponding IP above remains unchanged, so 192.168.10 actually hasn't changed here. Any changes are only within this. We say the latter part of the host position will change. For example, if we want to calculate its network address with the network bit set to 0, then in the future, we can calculate that 192.168.10.0 is its network address. And what about our broadcast address? In this process, all host bits are set to 1, and finally, we perform a calculation. The 8 ones converted to decimal is 255, so here we can calculate its network address as 192.168.10.0 and 192.168.10.25, which are its network address and our broadcast address, respectively. Now, the total number of IP addresses is the power of 2 to the number of host bits, which means 2 to the power of 8 is 256. However, for usable addresses, we need to subtract our network address and our broadcast address. These addresses cannot be used, so there are actually 254 usable addresses. I want to allocate these 254 addresses to 2 departments. Why? For example, right now we have a cake in our hands. This cake is originally enough for 4 people. But if I give it all to one person, they can't finish it. So I might as well divide it into 4 parts and let everyone have some. So now, in this context, it's like subnetting. Originally, I could only allocate one network segment to one department, but now I can split it in half and allocate it to 2 departments. However, you need to be careful here. If I allocate too much to one department, can I give the unused addresses from this department to others? No, once an address is allocated, that address or address segment cannot be used by others. So, how do we perform subnetting here? We use a technique called Variable Length Subnet Masking, VLSM. How is it done? It involves borrowing one bit from the network portion to the host portion. The network portion moves to the right. If the network portion increases, then the host portion decreases and it shifts backward, which means it no longer adheres to the standard A, B, C classes. In this context, if we hear about classes in a project, it actually refers to following the A, B, C standards according to the established norms, using a 8 prefix. Using a 16 prefix calculated as 2.14, if we have an address like 172.16.0.0, its original subnet mask is 0.16, but if we apply a 0.14 here, this is called classless. In other words, not adhering to the initial standard is referred to as classless. In this situation, how do we increase the network bits? We need to shift our subnet mask to the right. After shifting the subnet mask to the right, we calculate the number of bits in the subnet mask, which is 255.255.255. Here, each 255 represents 8 ones. This is 8, this is 8, this is 8. 3 8s are 24, plus 1 more because our network bits have shifted to the right, and our subnet mask has gained 1 more bit. What? So here we should have 25. So here in the subnet mask, we borrow this bit as our network bit. However, borrowing it can result in 2 scenarios. It could be 0 or it could be 1. Now let's first take a look here. If I want to calculate the number of hosts, I shift the subnet mask 1 bit to the right. I shift the subnet mask 1 bit to the right, so what is the host bit now? The host bit is 32 minus 25, which equals 7. In this process, when we calculate the number of addresses, it is 2 to the power of 7, which is 128. However, in this process, I cannot use the first and last addresses of each subnet. So for each subnet, you need to subtract 2 addresses, which is 126. This is like dividing a cake. We cut it in the middle. We can give the left part to one person and the right part to another person. Now, what is the range of the subnet on the left and right sides respectively? We need to first look at 2 scenarios here. If in this situation we take 0, then what about here? The 0 bit is fixed because these are part of our network bits. As for the host bits, I set them to 0 to calculate its subnet, and the result we get is 192.168.10.0, which is the network address of our subnet 1. Besides this, if I borrow this bit as 1, then in this process, this bit along with the preceding numbers are fixed as our network bits, and our host bits are set to 0. When we perform another conversion here, converting it to decimal, it becomes 192.168.10.128. Through this, we can calculate its current subnet range. What is it? Now it has been divided into 2 subnets. If in this process, in the future, we calculate its usable address range, we actually calculate its network address and its broadcast address. For example, if this bit is fixed as 0, it means our network bits remain unchanged and only our host bits are variable. In the smallest case, when all remaining host bits are 0, converting it to decimal gives us 192.168.10.0. Our day broadcast address is when all host bits are 1. In this case, the first bit is 0, and the rest are all 1s. Converting it to decimal gives us 127. From this, we can calculate its subnet. It is our range from 192.168.10.0 to 192.168.10.127, but these 2 addresses cannot be used. This means the addresses we can use in the future are from 192.168.10.1 to 192.168.10.126. This is the usable address range for our subnet 1. For subnet 2, it is the same in this situation. First, we need to calculate its network address and broadcast address. In this context, our network bit is fixed after being assigned a value. If it is set to 1, then this bit, along with the preceding address, must remain fixed because they belong to our network bit. As for the host bit, I set it to 0. Now, during this process, convert it to decimal. And after conversion, it becomes 192.168 on 10.128, which is our network address. The broadcast address is when all the host bits are set to 1. Although this bit has been borrowed here, we still need to convert the entire thing into a time frame. After conversion, its address is 192.168.10.255. Now, in this context, we also cannot use these 2 addresses, so in the future we will look at the usable IP address range. In fact, it's 192.168.10.129 to 192.168.10.254, which is an available address range for us. Next, let's take a look here. If I currently have a Class C network segment of 192.168.1.024 in my entire network, and now we want to use a variable length subnet mask to allocate this IP address to 3 subnets. Now in this context, let's assume, for example, a network with 10 hosts. We need to calculate the number of host bits we need to use. In other words, I need to have 10 hosts here, 10 computers, 10 IP addresses. So in this case, 2 to the power of the number of host bits minus 2 must be greater than or equal to 10. In this context, when we previously calculated, for example, the number of usable addresses, it was always 2 to the power of the number of host bits minus 2, which equals our final result. So, in this case, it's essentially a formula, right? In this context, we already know how many host addresses will be allocated in the future. Now, we just need to calculate how many host bits we need. If in this situation, n is greater than or equal to 4, how many powers of 2 minus 2 do we need to calculate to be greater than or equal to 10? If here, 2 to the power of 4 is 16, then my network bits need to shift 4 positions to the right. Now, in this process, we finally calculate how many subnets there are, which is 2 to the power of 4, equaling 16 subnets. If these bits are borrowed here, our third step is to calculate the subnet's network address. It's possible that for subnet 1, these 4 bits are all zeros, or it could be subnet 2. In this case, the first 3 bits are zeros. The last bit can vary between 0 and 1. Each bit can change between 0 or 1. Here, we need to calculate each subnet segment based on the variation of these bits. For example, in the case where all are zeros, and then, say, 1 bit is 1 and 0, 10. And then you can calculate H12-811, and after that, 0100, deducing the various changes of these 4 numbers. Each bit can be 0, and each bit can be 1. After calculating all possibilities, there are actually 16 subnets. This is our subnet encoding, meaning that in this process, we can allocate this segment to more computers, more departments, and more network segments. For more people to use, if you want to learn about Huawei certification technology, or wish to obtain the Huawei certification question bank, please send me a private message. I can also leave more information below the video.